A particle starts from origin, from rest, and moves with a uniform acceleration along positive x-axis. Identify all the figures that correctly represent the motion qualitatively. Yesterday we have actually analyzed the situation qualitatively, if you remember. A acceleration, V velocity, X displacement, and T time. Moves with a uniform acceleration. That means AT diagram is going to be horizontal line. Okay, so A is correct. It starts from rest. Okay, so VT diagram is going to be a line passing through origin. Like V equal to U plus AT, but initial velocity 0, so B is right. Now what about X here, XT diagram? Because the motion is uniform acceleration motion, we can bring in S is equal to ut plus half at square. But initial velocity is 0, so it will be half at square. So it will be parabolic. Okay, this won't come because time cannot be negative. So even powers of t, so it must be symmetric about the other axis, x-axis. I have told you this in the rules of curve tracing when we were discussing functions, right? Remember, if it is if it has even powers of t, that's horizontal, it has to be symmetric about the other axis. Okay, so this is x. So option D is right. Well, D is also right. So identify all figures that correctly represent ABD of D. Similar one. Question 8. All the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. Okay, let's first take a look at all the curves. Okay, velocity time is first. Okay, option A is velocity time. Option B is velocity positions. Option C is distance time. Okay, distance time. And option D is position against time. Okay. Now look, velocity time diagram is a straight line. Okay, so VT diagram has constant slope. Okay, VT diagram has constant but negative slope. Okay, do you understand that? VT diagram has constant but negative slope. Okay, constant but negative slope. What does it mean? It means, look, if this is the rectilinear motion path, okay, the x-axis, okay, let's say the particle is here at time t equal to 0, I'm not showing origin, its velocity is positive. Its velocity is positive. Okay, velocity is. What about acceleration? Acceleration is negative. So this will lead to a decrease in the velocity. Okay, it will lead to decrease in the velocity. And what does this point represent? This point represents the point of direction reversal. Okay, so the acceleration has taken care of the velocity in that direction, and now the body will start moving in the other direction. Okay, and then it just goes up. Okay, kind of similar to simple harmonic motion, but here the acceleration is constant, their acceleration is not constant. Okay, now what can we say about velocity against position? Okay, what can we say about velocity against position? Look here, velocity against position. Okay, now I can choose origin anywhere I want. Okay, I can choose position anywhere I want. But if I want to fit B with A, or if I want to try to find, if I want to find whether B is related to A, I must choose this point itself as my position. Which one? Initial position. Okay, when the velocity is such. Okay. So look, suppose this is origin. Okay, suppose this is origin. the body is going to travel to this direction, acceleration is still leftwards, but here velocity is a null vector. Okay, velocity is a null vector, and again in the other direction the velocity is going to be, well, the body is of course going to travel along the same path, so it will have same positions. Okay, so B matches with A. Okay, B matches with A. Do you agree to this? Okay, matches with A. Okay, now let's go to C and D. Okay, position against time. Okay, so position is first increasing and then decreasing. Do you agree? Position is first increasing and then it is decreasing, and velocity is 0, and this thing has a horizontal tangent here at the midpoint, right? This thing has horizontal tangent, and slope of xt curve is what? Slope of xt curve is velocity, right? So this matches with A. This matches with A. So the only thing that doesn't match is C. Okay, so C is not right. Okay, now I want to give you homework. Okay, the homework is plot qualitatively, of course, distance time curve for given situation. Can you do it? Okay, please do it till the body reaches its original position. Okay, you know how to do it. You had used equations of motion, v equal to u plus a times 1. Okay, and if you know how to use Desmos, assume some values and plot it there. And if you send me screenshots, that will be better. Okay, fine. Otherwise, we'll do it in our next class.